What if I told you? There's a very real chance we'll discover alien life in exactly 2041 days. Not in a science fiction movie, not in some distant galaxy, but right here, in our own cosmic neighborhood, 2041 days from now. That's less than 6 years, and according to leading astronomers, biologists, and NASA's own critical mission timelines, this specific window might be when humanity finally answers its biggest, most profound question. Are we alone in the universe? You might wonder, why such a specific number, 2041 days? It's not a random date pulled from a science fiction plot, it's a carefully calculated convergence point, a moment where multiple streams of scientific inquiry are set to deliver their most tantalizing results. This countdown represents the culmination of decades of planning and engineering. That's because, right now, we are living in a golden era of exploration, an unprecedented intersection of technological prowess and cosmic opportunity. On one front, we have our eyes turned outward. Powerful telescopes like the James Webb Space Telescope are performing cosmic archaeology, peering into the atmospheres of planets hundreds of light-years away. It's hunting for the chemical fingerprints, the biosignatures, that could betray the presence of life. And it's not alone. Soon, a new generation of Titans will join the search, like the ground-based Extremely Large Telescope and the Nancy Grace Roman Space Telescope in orbit, creating a dragnet for habitable worlds. Simultaneously, we are launching our most ambitious robotic explorers yet, turning our focus inward to the hidden oases in our own solar system. This is the second, more intimate front in our search, and the 2041-day clock is ticking down to the arrival of these emissaries. First, to Europa, Jupiter's enigmatic ice-covered moon. Beneath its frozen shell lies a saltwater ocean, with more water than all of Earth's oceans combined. Is it sterile, or is something swimming in its dark depths? NASA's Europa Clipper is on its multi-year journey to find out, performing dozens of flybys to map the ocean and taste any plumes of water vapor erupting into space. And Europa isn't the only tantalizing target. Saturn's tiny moon, Enceladus, stunned scientists with its geysers of water rich in organic molecules, the building blocks of life. Future missions are being designed to fly through those plumes again, this time with instruments built to hunt for life itself. Then there's Dragonfly, a nuclear-powered car-sized drone, set to fly across the bizarre landscape of Titan, Saturn's largest moon. It will hop from site to site, sampling a world where rivers of liquid methane carve through mountains of water ice, searching for clues to prebiotic chemistry. Each of these missions, from the atmospheric data gathered by Webb to the direct sampling of ocean worlds, has one primary goal: to hunt for life. Their arrival windows, their key observation periods, and their data downlinks all converge within that 2041-day time frame. This isn't a prediction of discovery, it's a forecast of opportunity, the moment our best instruments arrive at our most promising targets, all at once. But hold on. When we say alien life, we don't mean little green men waving at us. The first evidence will probably be small, tiny microbes clinging to alien oceans, strange chemical fingerprints in an atmosphere, or molecules that just shouldn't exist without biology. And yet, this would still change everything. Imagine the moment we detect methane gas coming from an exoplanet hundreds of light-years away, or the instant a probe finds amino acids bubbling in Titan seas. It means life isn't rare. It's not just an Earth accident, it's a cosmic rule. How do we even look for something we've never seen before? The answer, incredibly, is written in starlight. Our primary method is called transit spectroscopy. As a distant planet passes in front of its star, a tiny fraction of that starlight filters through its atmosphere before continuing its journey to us. The trick is in the light. Every atom, every molecule, leaves a unique fingerprint when light passes through it, absorbing specific colors and creating a barcode of dark lines in the spectrum. By analyzing that barcode, we can deconstruct an alien sky from light years away. This allows us to tell if an atmosphere contains water vapor, carbon dioxide, or something far stranger, like oxygen or methane in amounts that scream, "Life is here." We're searching for a chemical imbalance, for example, finding large amounts of both oxygen and methane. These gases naturally destroy each other, so finding them together suggests something is constantly replenishing them. The most powerful engine we know for that is a planet-wide biology. But the universe is tricky. volcanic outgassing or strange photochemical reactions could mimic life's signature, creating false positives. Every tantalizing hint must be rigorously checked. Beyond sniffing atmospheres, we're also learning to take direct pictures. This is the monumental challenge of direct imaging, capturing the faint whisper of a planet next to the deafening roar of its star. Using sophisticated internal masks called coronagraphs to block the star's glare, we can resolve these worlds as single points of light. And then there's the search for technosignatures. Instead of biology, we look for technology. This isn't just listening for a hello message. We're scanning for the background hum of a civilization, their communication grids, industrial pollutants, or the heat from cityscapes on a planet's night side. This grand search is powered by a new generation of technological marvels. Right now, JWST is our pioneer, already finding planets with clouds of water vapor, but an entire fleet is on its way. The Nancy Grace Roman Space Telescope will conduct a vast census of worlds. On the ground, giants like the Extremely Large Telescope and the Giant Magellan Telescope will use mirrors of unprecedented scale to dissect atmospheres with breathtaking detail. And the Square Kilometer Array will listen for faint technosignatures across cosmic distances. These are the tools of our quest, and with them, humanity will have its first proof of aliens, without ever leaving Earth. That's why 2041 days isn't a random guess, it's the ticking clock of discovery. By the late 2020s and early 2030s, NASA, ESA, and private companies will flood us with data, tens of thousands of exoplanets, dozens of icy moons, and new artificial intelligence models combing through the signals. It won't be a question of if we find life, but when. And when that breaking news alert hits your phone, it won't just be science, it will be the single most transformative moment in human history. Think about it. In just over 5 years, every human alive today could know the answer to the question that's haunted us for centuries. Maybe it'll be microbes beneath Europa's frozen crust. Maybe it'll be a faint chemical whisper from a distant exoplanet. Or maybe it will be something even stranger, something we can't yet imagine. All we know is this: the countdown has already begun. 2041 days until the universe reveals whether we are truly alone. And when that day comes, nothing, our science, our religions, our philosophy, even our sense of identity, will ever be the same again. What if I told you, there's a very real chance we'll discover alien life in exactly 2041 days? This isn't a prophecy, it's a calculation, a date marking a critical convergence point when our most advanced instruments will simultaneously scrutinize the most promising locations for life. Not in a science fiction movie, not in some distant galaxy, but right here, in our own cosmic neighborhood. For millennia, we have looked to the heavens and wondered. The question, are we alone, is woven into our art and philosophy. It has driven us to build ever more powerful eyes to scan the cosmos. For all of history, that question has remained speculation. Until now. We are in a golden age of exploration, armed with instruments of unprecedented power. The James Webb Space Telescope is tasting the atmospheres of distant worlds, searching for the chemical fingerprints of life. This is where looking becomes seeing. This quest is a truly global one. It's a symphony of human ingenuity, conducted by thousands of scientists and engineers, pushing the boundaries of what's possible, all focused on a single, shared goal. From every continent, we are looking up, together. When that breaking news alert hits your phone, it won't just be science. It will be the single most transformative moment in human history. The journey to that moment is underway. It's a story told in the hum of supercomputers and the precise movements of robotic arms. Every component is sterilized, every circuit tested, to ensure we don't contaminate the worlds we seek to explore, and to guarantee the data is pristine. These missions are our proxies, our senses extended across millions of miles. Launched from Earth on pillars of fire, they travel for years through the void, built to survive the harshest conditions, all to answer that one fundamental question. And when the signal arrives, it will be scrutinized, debated, and verified by a global community of experts. The tension in those rooms will be immense, as humanity holds its breath, waiting for confirmation.
This just in. Scientists report possible evidence of extraterrestrial life. Details developing now. The announcement will likely point to one of a handful of prime candidates. These are worlds that show the most promise, where the ingredients for life as we know it water, organic molecules, and an energy source are all present.
Think about Europa, the icy moon of Jupiter, with an underground ocean twice the size of Earth's. NASA's Europa Clipper, launching in 2025, will reach it in less than 6 years. It will perform dozens of low-altitude flybys, using ice-penetrating radar to map the ocean and analyzing water plumes erupting into space, tasting the ocean for biosignatures without ever having to land. But Europa is just one possibility. The Dragonfly mission will explore Titan's organic dunes. All we know is this: the countdown has already begun. 2041 days until the universe reveals whether we are truly alone. Would you be ready for the day we find aliens? Subscribe for the countdown.